all. You should give it a good attention, right? So once again, I'm Emmanuel Fajembola. I'm from Achdut Global Limited. We are a company that prides ourselves in excellence, and our sole purpose is to lead an excellent example in the geospatial world, right? And that is exactly what we are doing. We want to raise everybody to a level where Nigeria is one of the competitive country in the geospatial world, and I believe we'll do that one step at a time. Of course, we are not there yet, but we are on a journey, right? And I hope you take this journey with us. All right. So the course is Introduction to GIS, and we'll dwell more. We'll talk because I really want you to understand what this is all about before we get into theory. And we are considering 3 softwares in these 2 days. We are considering the QGIS, we are considering ArcMap, and we'll be checking ArcGIS Pro. All right. So please pay attention. So what we want to achieve from this course is we want you to understand GIS. GIS is Geographic Information System, and we want you to understand how it works. We want you to understand the principle of collecting, managing, and visualizing spatial data. All right. And we want to introduce you to the basics of GIS analysis. All right. So all of this are what we hope that you learn from this course. All right. So diving into it, GIS is a combination of two specific words, two big words that we are combining together. And the first one is geographic. The second one is information system. They can both stand on their own and achieve a good purpose for themselves. But we have in the geospatial world, we have combined both together to achieve a purpose. So geographic is just based on or derived from the physical features of an area. You know, when we talk about geography as a whole, we are talking about the study of the earth, right? So if you are talking about geographic as a word, we are talking about something that is derived from the physical features of an area, all right? And if you are talking about information system is all about a structured set of components that collect, process, store, distribute information to support decision making and control within an organization. So information system is just like a system that collects, process, and store information. All right. So we are combining both words together now: geographic, features of an area, and a system that collects, process, and store data. So while geographic is there, it will no longer be just any data. It will now be spatial data. That brings me to explaining what spatial data means. Spatial data means that it is a data that has in a simple layman term. Spatial data is just a data that has your X and Y coordinate attached. It means it's a location on the planet Earth. So if you are talking about spatial data, you can talk about coordinates, you can talk about houses, you can talk about roads, you can talk about trees. Do you understand? Collecting data from these things, attaching an X, Y to it makes it a spatial data. I hope you guys can still hear me. All right. Can you guys still hear me, please? Ifeoluwa, thank you very much. Mr. Toby, thank you guys. Oh, I see you. Inkem, I see you. All right. So let's get back to it. So spatial data is a data that has XY. Is a data that you can specifically say this is the location of this data. And moving us forward, GIS helps us to understand patterns, relationship, and trends in geographic information, right? So there are 5 components of GIS, and they are key. It is all about what we do in GIS. GIS is not, it's not all about entering the bush. Of course, you enter the bush, even if you're a GIS specialist, if you're a GIS developer, if you're a GIS anything, there will be time for you to enter the bush and you learn that here. But then you do more of what you do in your head and on your table, right? Just with your screen in front of you, right? So GIS is also like, as surveyors, let me mention that GIS is like an aspect you can decide to dive into, you can decide to settle into. I was stating last week that cadastre, which is the survey of 4 corner and I mean, survey of land, giving XY to land and all that is saturated. Cadastral surveying is saturated. What I mean by saturated is we have enough persons practicing as cadastral surveyors, practicing cadastral as surveyors, right? So, I mean, GIS is an option for you. Though, of course, we are not getting all the value in Nigeria, but I'm sure with the technology going on right now, we are getting to a time where we start the value for GIS. For GIS. All right. Akombi, I see you. Your face show. All right. So the first component of GIS is hardware. Hardware talks about computers, GPS devices, servers. Hardware talk about everything computer you use in GIS. Talk about your mouse, your PC, your GPS devices, your drone for people that wants to like take pictures and mosaic. For I mean, hardware. And the next component is software. Software is like what we are learning in this course. Software talks about your ArcGIS, your QGIS, your ArcGIS Pro, your MBI, your a lot of softwares. We use a lot of softwares in GIS. So I don't know if I'll be running ahead of myself to mention to you that GIS is not a software like we have defined in the definition. So, I mean, until I got myself into what it really is, I used to think GIS is just software, like ArcGIS is GIS. I'm sure some of you, especially probably 100 level, 200 level students, still think that everything GIS is about is ArcGIS. Once you just say GIS, what the next thing in your mind is ArcGIS, QGIS. You know, GIS is not a software. It's software. The softwares are just a component of what GIS is all about. So we have talked about the hardware, we're talking about the software, which we are here to learn, and the next component is your data. And I have said that in GIS we make use specifically of one major data, which is our spatial data. But you can't just deal with your spatial data. Like I said, spatial data is anything on the surface Earth that you can attach your XY to. You can tell us that this is exactly where this thing is, and we can meet it there. So for us to describe and explain our spatial data, we need another data, and we call it attribute data. So the attribute data is just gives the descriptive information about your spatial data. So attribute data, if I'm talking about a house in Ikoyi, the attribute data will be about what is the extent of the land the house is sitting on, what is the color of the land, how many bedroom is the land, do you get the features. Attribute data is always the data that describes a spatial data. So attribute data in itself in GIS can't stand alone, but of course, for us to understand what you're doing, you need attribute data to describe your spatial data. Moving on, the fourth component of GIS is methods. So in this training, we'll be using a lot of approaches to attack problems, right? So one of my lecturers when I was in school, we say that he wants to give us problem. I was in secondary school, and our mathematics teacher is all about problem. He's always problem. He wants you to bring him problem, and when he's leaving the class, he wants to give you problem. So what GIS wants to solve as an entirety is problem. So approaches to this problem is what we call methods. All right. So wow, sorry. This set is making me all right. So I just took notice of that. So to approach a problem, to solve a specific problem, you need an approach, and that approach is called method. Is the workflows you decide to use. So for some people, of course, there are some problems you want to solve. There are some jobs you want to do that you need to automate. That's where your coding will come in, Python, JavaScript, and all that. You need to automate. Is one of the workflows. You create a workflow that makes your job simple, that makes it Okay, do you understand? That's methods. And the last component of GIS is the people. The people are the professionals that use. So we have like two major persons that we consider in GIS. That I think three: the people that use it, the people that create it, and the people that makes decisions with it. All right. So take for example, we are creating a map of Lagos State, and of course, some people will create the map. A lot of people will use it for different things. All right. And a lot of people will just like see it and just appreciate the artistic design and all that. Yeah. So the people, very, very important parts of GIS, component of GIS, right? So moving on, how GIS works. So I don't want you to get bored. I want you to understand these things. I'll still share the document. But I want you to understand these things because this is the basics on which learning our softwares we build on. How GIS works. GIS works simply by, I've told you about spatial data. We combine layers of spatial data and we link these layers with descriptive data, which is the attributes, and allow creating analysis and visualization to support the decisions. So let's create a scenario. We want to like we want to like map a flood prone areas. So the data we need our rainfall data, elevation, settlements, and we need to like match all of these data together on one map. And we don't just map them. Like I said, we are saying about rainfall. Rainfall of which year specifically are we talking about? Attribute data. Elevation of which of the locations? Are we talking about the elevation of the mountain, the elevation of the attribute data? Settlement layer, which I mean, what is which house, where is this house sitting on, what is the access road to this house, and all of that. Attribute data. Do you understand? So we use attributes data to link these layers together, and we query. So if you are talking about a mapping flood prone areas, we want to know what is the distance of each settlement to the river. What kind of elevation exists between, what kind of topography exists between the around the settlement and the river? I mean, is the river uphill and the settlement is downhill, or is the settlement downhill? And do you get, we have to like ask those questions. That's querying. And we can query, if there are a lot of querying we can do. We can buffer, we can ask questions with GIS. Then analysis. Analysis will come straight to it's more of asking questions to you make analysis on, if this is this, what will be the result? There are a lot of analysis we do with GIS. Then visualization will boil down to what you later call map. All right. So if you're following, let me see you give me a thumbs up. Thumbs up if you're following. Oh, Solomon, I see you're the first person. All right, guys. I see you. Jamil, bless you, precious. All right, thank you, guys. So moving forward, collecting, managing, and visualizing data. So I will try to hasten up as I move ahead. Spatial data collection methods. We are surveyors, right? We are surveyors, and one of the most regular ways we acquire our data is by field surveying. It's by field surveying. 100 level students, you have done what's that? Chain survey. You have done compass survey. You have worked with theodolite, worked with total station. I mean, these are all ways of getting data on the field as surveyors. Field survey, you can use your GPS, you can use total station, you can use drone. The next method is by remote sensing. I'm sure probably 300 level upward would have done something around remote sensing. Remote sensing is just talking about assessing satellite images that satellite have snapped. Then area photos. That's where if you guys have done photogrammetry, right? Talk about area photos, right? Digitizing, converting paper maps into digital data. So there are two kind of data we have raster and we have vector. So if you're digitizing, you're converting a raster data to a vector data. I'm sure I hope time will permit us to get there. Then existing data sets. There are some existing data sets. Like we have a lot, like right now, Nigeria has a platform that that has been working. Sometimes it stops working, and I think it is working again. It's trying to work again. The grid 3 data, right? Grid 3 data is a government data that exists, and grid 3 data, and we have other open source data like OSM. We have a lot of open source data that exists, so you can leverage on existing data, right? I'll give you some names of um, um, open source data that you can access, right? So managing spatial data, we store spatial data. One of the ways of storing data, spatial data that is most effective is by using your geodatabase. So we have file geodatabase, we have personal geodatabase, and a lot of them. Geodatabase is just like a file, and a file online that can combine all of your data into one and can allow you send it to another person without altering anything you've saved into it. It's online, it's not saving. So of course you can save on your desktop, or you can also save like in the cloud. So your database like file every of your data and allow you to even send to someone else without altering anything there is there. We organize our data by layers, projection, and metadata, maintaining data quality. As you all know, in surveying, accuracy, where precision is also very, very important. And once you talk about GIS, sincerely, you're diving into tech, and it's really, really, it's really, really amazing. It's really, really amazing. Then visualizing data, like I said, in a layman term, you just call your visualizing your data map. All right, we create map with symbology, color coding, and labels. You use thematic mapping to show patterns. Combined to the, it's all about map. It's just like presentation, right? So it's just like you're drawing a plan in surveying, or you're doing your 3D designs, all right? So we'll be introduced to GIS analysis. I mean, when you're making analysis, like I said, it's more like your query. You are asking questions, and you hope to get answers with these questions. So you're asking, where is the house? Where is the flood? Where did the flood happen? Where is the flood going to happen? Which bridge are we talking about? There is an outbreak. So just to mention, GIS works in every field. You can apply GIS in every field, ranging from health to the oil and gas, to energy, any field at all you can think of, GIS is functional. So talking about health now, there's an outbreak probably of coronavirus. Where did it happen? Where did it begin? What are the things to consider in preventing the virus going forward? Do you understand? That is the way question. What is near? Question of proximity. So that we can Andy can talk about buffering, Andy. So you are asking, okay, the flood that happened, to prevent it from happening or to save the lives, or we have a projection of a flood happening, all right? So to save the life of people, where is near the river? How many meters do we have settlements near say Benue River or River Niger or something? Do you understand? Then what overlaps with, you're saying on your map, what is sitting on another, what's the proximity of distance to each other? And the question of pattern, spatial distribution, what is happening? So and the case of viruses will come to mind. What is the pattern that happened in this area that might have like suggested prompted the outbreak of the disease and all? So common analysis in GIS: buffering, overlay analysis, spatial queries, surface analysis, and so on. So yeah, we are moving straight to practicals. And like I said, we are going to be learning QGIS, we are going to be learning ArcMap, and we are going to be learning ArcGIS Pro. So if your friend has not joined, go and tell them now that you will not help them to do assignment. You will not help them to they should come and join and learn by themselves now. All All right, so this is just a beginner level, and like I said, if you wish to proceed, we have plans for that, and you can always reach out, probably through your schools, or you can reach out directly, right? So overview, we are comparing the three software. QGIS is open source. It means you don't have to pay. You can download it anytime, any day. It works on Windows, it works on Mac, and works on Linux. Interface is classic and flexible. It's free. That enables plugins. Plugins are extra softwares that you can bring in that will make your work easier, and it's flexible, right? ArcMap is proprietary. It works on Windows only, classic and static, widely used, and it's stable. Stable, right? ArcGIS Pro is modern, so as at now, there is nothing like ArcMap again. As far as S3 is concerned, it has been discontinued. What we have now is ArcGIS Pro, and of course, ArcGIS Pro is paid. You can't even access it if you don't have an organization login, right? Or a personal login, and that has to be paid for. All right. Yeah, I don't want to say what I wanted to say, but yeah, Nigerians, people do a lot of things around. People have still found their way inside it. So yeah, it works on Windows only. It has a modern ribbon style. I will show you the how it looks like by God's grace tomorrow. And of course, we can now work like easily on 3D maps and all of that easily, very easily on ArcGIS Pro. So yeah, I'll share you this thing. Getting started with these guys. This is how you can do. This is what they support and all of that. So let's run. And like I was saying the other time, we have what we in GIS. The data we use in GIS. We have our vector data. We have raster data, and we have attributes data. Right? I've explained attributes, and raster is just talking about images. It's just talking about images like paper image, whatever images that use pixels, right? And vector data is talking about points, lines, and polygons. That's what a vector is. So when we start, I'll show you example of raster and vector data and attribute data also. So, okay, are you guys following? Are you guys following? Are you guys following? Are we learning? Are we learning? Okay, thank you, thank you. All right, all right, all right. Anita, I hope you guys are learning. I have plenty of questions to ask you guys today. So please take notes, take notes. Osakwe, I think I'm seeing your name very frequently today, and Ifelua. All right, Precious, I see you. Okay, so these are the common file formats that we use, sorry, in GIS. You'll see shapefile like very often. If you learn and prefer to use file database, you use .gdb very often. GeoTIFF is for raster. It's one of the most preferred because to save your picture in high quality. And talking about vector, most preferred is .csv. That's what Oyinda was trying to open on Excel the other time. That's a .csv data. All right. So comparing the user interface, you can read that later. I mean, still see it. Basic operations, you can add data, you can do symbology, attribute data, labeling, and layout view. I hope we'll be able to touch all of these today. So we're working majorly on ArcMap today. Please get your pen, get your biro. It's going to be very interesting. And basic analysis you can do on ArcMap is access via ArcToolbox. You access these tools via ArcToolbox here. You can profile, you can clip, you can intersect, you can do spatial joining. All right. So let me quickly explain buffering. Buffering is just asking the proximities. Like I said, we have a news from, is it FEMA now? What is this? There's a body in Nigeria now that regulates water bodies and all that. So probably they have a projection that rain is going to fall at so date, and everywhere that has river is prone to flood. So we want to, like, for example, in Benue, we want to ask what where are the settlements around River Benue, and what is the distance between them? At what distance is it likely that we have this water enter people's houses, right? And we can like make that analysis by buffering. We can buffer, say, show me the settlements that are 50 meters around the river, and it will bring it out for you. All right. So that's buffering. Clipping means that probably you have a shapefile, you have the picture of the whole Nigeria, and you want to just cut out Lagos State, or you want to just cut out the University of Lagos. That's your area of interest. You can bring in the shapefile, the University of Lagos, and you can tell ArcMap to clip the image to University of Lagos, to extract University of Lagos out of the raster data, and you have your data intact, intersect, spatial joining. All right. So not to waste much of our time, then you export project as MXD, export your map as PDF. So yeah, let's go straight into ArcMap. Let's go straight into ArcMap. So I'll be sharing my full screen now, and I'll launch my ArcMap. Okay, so if you're ready, let me know that you're ready. Let me know that and if you have a question, please, this is a good time to bring in your question on what you have done so far. So if you're ready, please keep the emojis coming. Let me hear you. Let me see you. Let me see you. Let me see you. Come on, come on. Precious is giving me thumbs up. Okay, Precious, thank you. Samuel, thank you. Ben, I see you. All right, so ArcMap is loading. Wait, how many of you have ArcMap on your PC at the time? If you have ArcMap, just give me a thumbs up. If you have ArcMap on your PC at this time, give me a thumbs up. Let me see you. ArcMap. Okay, nobody. I can stop. I mean, there's no reason why I teach you ArcMap if you don't have it. So how many people has ArcMap? Let me see your thumbs up. Okay. All right. Okay. All right. So sharing my screen now. Yeah, so these are everything ArcGIS, the softwares that I have. You can see ArcGIS Pro, you can see ArcGIS Globe, you can see ArcMap, you can see Asking, I mean, you can see Python. I mean, these are what I use, and all of them has different purposes they serve. They have different purposes they serve. So yeah, while we wait for it to load, any question? Any questions so far? You can see my ArcMap is loading, and soon enough you see it appear. Yeah, that's ArcMap right there trying to load. All right, any questions so far, please? Any question? Any question? Any question? If you don't have question, I will ask you question. If you don't have question, I'll ask you question. Ben, are you there? Ben, are you there? You can unmute, please. I just say Ben. Ben has been my friend from last week. And the guy that won my giveaway last week, is he on the call? Okay, somebody won my giveaway last week. Is the person on the call? All right. Akombi, are you okay? Ben, oh, it's you. Okay. Akombi, are you there? Akombi, are you there? Okay. So of course, ArcMap takes a while to load sometimes. So bear with us. But yes, ArcMap is loading. So yeah, before we get ArcMap to load completely, we are also going to work on Google Earth Pro. Google Earth Pro. You can see my screen, Google Earth Pro. So Google Earth is also loading. And what we want to do is around your school. So we're working on the University of Lagos. Don't forget we said that spatial data is any data that you can attach your XY coordinates too. We have less than an hour to go, and I hope we make good use of it. So I'm opening my Google Earth Pro, and this is like the easiest way to get your imagery. Google Earth Pro is, of course, open source. You can go there anytime, any day, and you can also download images. So you can save images on Google Earth Pro, and you can also download images on Google Earth Pro. So I have an image that I will still load it later. This is a Google satellite map image, and it's about 17 gig. That's crazy, right? All right, so it was downloaded in a way web. We'll get there. So on my Google Earth Pro, I believe you guys can see my screen. You come to search, and you enter your area of interest, University of Lagos. All right. Please, can you guys see my screen? Can you see what I'm doing? All right. Okay, thank you. So University of Lagos, you enter search. So Google Earth Pro works with your internet, so you have to like give it time to breathe. So you consider that internet providers will do their software its own, You guys are close to the water. Okay, so this is the University of Lagos, gladly sharing boundary with water. So I've been around the I guess we look for woman. And yeah, so University of Lagos, and we are going to like pick an area of interest. We are going to pick an area of interest, and we can say, okay, somebody should just unmute and let me know where exactly we should focus on. You can see Federal College of Education, University. I think this is like the stadium, like sport complex, right? Okay, this is all right. Who will unmute now and tell me where to more? All right. Okay. All right, you guys are shy. You're shy. Okay. So we'll be working on okay, somebody talking. You want to
since you have already suggested sports complex, you can just focus on sports complex.
Thank you very much, Mark. Thank you, Mark. All right, so we will be focusing on sport complex and the areas around. So yeah, we are on Google Earth Pro and we've gotten out our area of interest. The next thing we want to do is to clip it out. Want to clip out our area of interest. So like I said, this is, once we bring this out as an image, this will become a raster data. And for us to convert raster data to a vector data, we need something we call georeferencing. That is simply attaching physical, real life coordinates to a map, to a paper map. So so it's just the process of converting raster to vector by attaching coordinates to it. Do you get? So for us to know which coordinates to apply, we would have to like pick points. So where I went to is this place. You can see my screen. Add place mark. Would add a place mark. We can rename it as L Unilag. No, Unilag UL1. Unilag is too long. So you like move this interface away and place it where you want to be. So it's just like we are setting controls. We are setting control points and want it to, we must ensure that they are spatially distributed. By spatial distribution, we mean that it must not be, your control should not be here. It should not be one-sided. They must be everywhere on your screen, on your map, right? And you must ensure that you don't have any control that is less than 4. Your controls must be 4 or more. Must be 4 or more. That's because you most times or all the times always have 4 edges on a map, on a picture. It's always almost like 4 corners. So for you to like place it well, you must spatially distribute your controls, right? So this is the 4th one. This is what spatial distribution means. I'm putting them at all the edges. That's if I'm using 4, they must be at the edges. Must be at the edges. I can decide to use more than 4. So depending on the precision of what I'm trying to do. So yep. So yeah, this is the 4th one. And don't forget we are naming UL124. This is the 4th one, right? So there are 2 major methods for georeferencing, but the one we'll use for this class is we are going to write out the coordinates of our controls. So as surveyors, I'm using controls. I mean, because you're a surveyor, you already know what control is. It's an established place, a distinct established place that you already have the coordinates. You already have the description of that point. You can tell me the X and Y, most times Z of that point. So if you notice, I was not writing out the coordinates while I was trying to fix this point. So I can just right click on each point and go to properties. Right click and go to properties. So what I would do is bring out my notepad where are you? So I'll just bring out my notepad and copy out my coordinates. So don't be confused if at all you open your own Google Earth and you're not seeing it in UTM. Let me write out this and tell you how to change it to UTM. So this is UL1, and that's the eastern coordinates. And yeah, this is the northern's coordinates. This is the eastern, that's UL1. So you must be sure that you didn't move this one, because if you move it, it will change. So yes, we have. So if you want to change the coordinate system on your Google Earth Pro, just come to tools. You want to change it to degree, minutes, seconds, decimal degrees, UTM. Just come to tools. Okay. So come to tools. Under 3D view, you see show lat or long, so you can decide which one you want to use. There's decimal degree, there's degree, minutes, seconds, there's degree, decimal. We have universal traverse Mercator, which is our UTM, and we have military grid reference system. All right, so for this training, we'll be using our UTM. We can decide to use decimal degrees. What is important is that we attach coordinates to the raster data and convert it to vector. So we have our UL1 out. So we'll place our mouse on UL2 and right click, go to properties, copy out and paste in your notepad. In your note, this attendance is actually not encouraging, but I just hope that you guys are here will make the most of this opportunity. All right, so that's our eastern coordinates. Then go back to copy the northings, and yes, you paste the northings there. And don't forget, try as much as you can not to move your control. So our control is not in situ, it can move. For people who knows what in situ means, I was the talk of the town when I was when I was in FSS, right, it was talk of the town. So we literally named the lecturer Institute because he told us what Institute means. Named the Institute. Okay, so this is UL3. These things copied. Yeah, so you have to be careful so that you don't paste the previous coordinates and don't allow human error in your data. Once there's human error, you are sure to have problem. Don't forget you are trying to solve problem. When you now have problem, trying to solve problem to fall, you know, that's that'll be a lot of problems. Yeah, so that's the fourth one, and we are going for the fourth one, guys, and we are getting there. You have Eastings, comma, then we'll go for nothings. It's not nothing, nothings. Nothings. English is hard, bro. Okay, yeah, so we have our coordinates out. We have it in, so like I said, we have two formats. We can save this and run it on our georeferencing page, all right, and that will be just fine. But for this class, we'll just enter them manually. So our ArcMap is open. You guys can see my screen. Is it on ArcMap there? Okay, yes, on ArcMap now, right? ArcMap, can you guys see ArcMap? Okay. Mark, do you have a question? Oh, you wanted to give me a thumbs up. All right. So on ArcMap, you can see my screen and you can see that the first thing that pops up is the recent screen. These are like the project I've like worked on in recent time. So it's like bringing everything out. But of course, I don't have interest in all of this. Don't know them for now. All I know is Unilag. So I'll come to new maps. So I'll click on new maps. I click on new map, then it's to blank map, gig. Okay. Okay, so as you can see, the screen has been activated. The screen has, how you know the screen has been activated is by seeing this. So you start seeing your unit on the screen. Don't forget, as we are going ahead, if you have a question, do not hesitate to ask. I can see somebody, Manuela. I will ask you a question very soon. Manuela Taku George, I believe she's a new student. I didn't see her last week. So I'll ask you a question. Please prepare for my question. All right, guys. So the screen has been activated. And the first thing, since we are working with UTM, as you can see here, this is the unit is confused. The unit is confused, and what we want to do is just data frame properties. So you just right click on the interface. You right click on the interface, come to data frame properties. Data frame properties. All right. On data frame properties, you locate coordinate system. In case when you click your own, it's on general. Just locate coordinate system on this surface, and you're looking for UTM, right? That projected coordinates. Look for projected coordinates. UTM. Another thing you need to know is if you're working with Menadatum or you're working with WGS84. So I think we are working with WGS84. So well, give away time. I told you guys and I shared the document about coordinate system yesterday. Now we are working in Lagos. You can tell me the zone, the UTM zone that Lagos falls under. I've already given you a result. You can see we are in Northern Hemisphere. So please, quick giveaway. Mark, Manuela, who can tell me the UTM zone that Lagos falls under? I told you guys yesterday, so I'm not moving on if I don't have an answer from any of you. So who is trying?
Zone 31.
I can't hear you. The person speaking, I can't hear you.
Zone 31.
What did you say, please? Okay,
Zone
excuse me.
31.
Come again, what did you say?
Zone
So
31.
31 what?
WGS 1984 Zone
Okay,
31.
zone 31 east, zone 31 north, south.
North. North.
Okay, you can chat me up after this call to get your giveaway. Right? That's correct. So we are going to look for zone 31 north. Zone 31 north. So you take notice that on ArcMap, you just like look for the northern hemisphere. We have that's already helped us to say northern or southern. So you open northern hemisphere and you look for the zone that where you're working. Zone 31. What said they said is zone 31. Yes. Oh, she's correct. All right. So we click OK. Okay. So can see that the coordinate here has changed to meters. So this is minus. Maybe this is somewhere in the ocean. All right. So the next thing we want to do is to go back to Google Earth, and as we have all our coordinates out, so you come to save image. So on this page, you just come to save image. If you can see my screen, you can see where save image is. That's if you're coming from your right, that's the third tool, save image. Save image, you click on save image. Toby, thank you. Others, please let me know that you are following. Let me know that you're following. Precious. All right. Thank you. So another thing you should do. So when I click save image, these options popped up. Then you come to map options, and you deselect. Okay, let me show you how these things, how it looks like when it first come up. So this is how it looks like. This is everything. It's giving me a legend, it's giving me the HTML, it's giving me the title. I don't need them. So you just come to map options. I don't need them because this map title map title is already covering my first control. This one is covering my second control. This Google Earth is covering my third control. So I don't need it. So I've just come to map options and uncheck all of them. Uncheck all of them. Just uncheck all of them and leave quietly, like you didn't do anything. You guys like my cap, right? Okay, so you come to resolution. It's I'm always on current, like on current default. Thank you. By default, it's always on current by default. Then we put it to maximum because you want to download a good quality image. Gone are the days when we say good quality images are not clear, but this is not, this cannot this cannot be used for some things, but yeah, it will serve us for what we want to do, right? So you click maximum. Of course, it will eat more data, but yeah, we'll go ahead. We'll go ahead. So save image. Boom. So next thing we want to do is to locate where we want to save our imagery to. So training, yes, obviously, GIS, and we'll name it Unilag. Okay, so our image will save. To take a time because we are trying to load a good quality image, which means that it will be heavier than just screenshotting this page. So it's downloading, guys. So while it's downloads, let me show you. Let me take you around ArcMap. So this is ArcMap. This is like the title page. You're seeing untitled because, please, am I too fast? Some people said I was too fast last week, and I'm just trying to buy us time, right? So, am I too fast? There's no purpose if I'm fast and you're not learning. So, am I too fast? I need responses. Am I too fast? No, thank you, Abigail. Who else is talking? Who else is talking? Am I too fast?
Sir, please can
Yeah,
you explain why you went to ArcMap in the first place?
I don't get it.
Like we're using Google Pro, Google
Okay.
Earth Pro. Then you went to ArcMap with the notepad values and the coordinates. I don't know why.
Okay. 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 So let me go over that again. Okay. So what I said is that where is Google Earth Pro? So why I went to okay. So for let me understand your question. Do you mean after we opened this one, why did I have to like go and open ArcMap? Is that what you're saying?
Yes.
Okay. Okay. So um working what we want to do, the major software we are learning is ArcMap. Do you understand? What we came to do on Google Earth Pro is to get our raster data out so that we can take it to ArcMap and make our analysis, convert it to vector, digitize and make our analysis. Do you understand? So our focus is ArcMap. Google Earth Pro is just to get us our data. So like we said, sources of data, when we were learning that, we explained that we call them direct sources. Direct sources is field survey. That's when you go there by yourself to acquire the data. And indirect sources are our imageries here and there. And we said we have open source, we have paid satellite imagery. This is a satellite imagery and it's open source, hosted by Google, right? So this is it. That's why we are here to extract our raster data out of this and we take it to ArcMap to work. Do you understand? And why I had to set the coordinate system on ArcMap is because I showed you how that we can work with a lot of coordinate system from here. So we decided to work with UTM from Google Earth. And what Google Earth works with is WGS 84. So that's why we went back to ArcMap to set our ArcMap to the same coordinates with the data we are bringing out from here. So I don't does that answer your question? Are you clear now? Okay, then. All right, all right. Okay, okay. Okay, so we are on 50% already, guys. And so let's go back to ArcMap to but on ArcMap, Ben, you understand everything I did to this stage, both ArcMap and Google Earth Pro. Okay. Every other person, please, are you cleared to this stage? Both ArcMap and Google Earth Pro. Oluwafemi, thank you. Toby, thank you. Who else? Please, I need you. We are like we are more than this on this call, so I need you guys to respond. Faith, Fatiu, thank you. Pose, thank you. Okay, Osakwe, you're raising your hand. You can talk. You can talk. You can talk. Was that a mistake? Osakwe, was it a mistake? Unmute and talk to me. Was it a mistake? Okay. Oh, okay. Our imagery is still downloading. I hope it will not be 800. It can give us that resolution. So, like I was explaining, this is our title page. It's untitled because we have not titled it, and then we have the file, edit, view, and all of these tools. All of these has things under them. Okay. All right. So this is for file. You can create new. You can open. You can save. You can explore this, guys. You can always explore it. Can always explore it. The data frame properties that we went to by just right clicking here. This is it under view. So we have layout view. We have data view. This is a direct replica of that here. So we have this is data view. We have layout view. Layout view is where you make your presentations, guys. This is where you come to make your map of Unilag showing that you have your region and all of that there. Then you have bookmarks. You have insert. Insert is what comes handy when you're designing your layout. You have selection. Selection is when you want to like make analysis. You want to select by attributes and all that. Geoprocessing. This is the buffer I was talking about. This is the clip. This is the intersect. And we'll have our ends on some of them, and you can customize this window. So guys, you can lay your hands on and explore this. And this is one of the most important tools on ArcMap. This is your Arc toolbar. Okay. So who is somebody has unmuted, please? Is this from me? Let me try. I'm myself. Oh, okay. Okay. So that's been rectified. Thank you. Okay, let's check Google Earth if that is done. All right, so we have our images saved, guys. We have our images saved. So we just need to confirm from here. So look at it. Unilag. I don't know why it took so much time. This is just 14 MB. So one thing I would advise is once you apply spatial data on this image, it literally comes to affect it here. So in case you make a mistake, you can't rectify it again. You will not have to go and save that image again from Google Earth. So what I always advise is to have a copy of the image you're working on a separate have the image of what we are working on a separate file. So I'll just place it on desktop. This is it here, so that once I work on it on ArcMap, it doesn't affect that extra one in case I need to use it again. Do you understand that? I hope you did, because it will save you a lot of trouble. So once you just start georeferencing, the spatial coordinates you're applying to it will start affecting where you save it to. So next thing is to add data. I want to bring in the image that we saved. The image that we saved. So you come to add data. Add data. So people that call data. So yeah, come to add data. We'll locate the this thing we are using, the file we are using. You just navigate into mine, and this is it, guys. So I'm clicking that. So it's telling me that these are the two things. Like I said, .tif is one of the best extension you can work with when it comes to imagery. If you want to work with Landsat data and all that, you have them .tif. As you want to make 3D analysis, right? LUSC and the likes. So take notice is telling me that the following data source you added are missing spatial reference information. Data can be drawn in that map, cannot be projected. Projection, you already know projection. Projection means that you are attaching just what we want to achieve with referencing. So yeah, we know that it lacks spatial reference, so, and that's what we want to do. So this is it. This is it. As you're seeing this thing now, this guy has it is here. This is a raster data because it's just an image. It's just an, if you point to this place, you're showing me minus something. I'm sure the coordinate of your sports center can never be minus 2122. All right, so it means that it's missing spatial reference. There are no spatial values attached to this image. That makes it a raster data. All right, so what we want to do is georeference. All right, that means we want to attach coordinates to this, and by changing, okay, another thing that why it's a raster data is not just because it lacks spatial reference. This is because it's an image. So this thing is represented in pixels. I think I should state that too. It's represented in pixels. By pixels, we mean as we are zooming in, you can see the small boxes. This is the qualification. This is what really like makes your raster data raster. So we want to change this pixel format image to a point line polygon, which will make it a correct vector data. I'm sure you never miss this. You're still in 100 level, 200 level, I'm sure you always meet it in your GIS exam. Raster data, vector data. If you learn it now for fun, you always just tick it. You just eat it like you're eating fun in your exams. I'm very sure if you are still offering GIS, even till master step, they will still ask you about vector and raster. Just finish my postgraduate, I wrote it, vector and raster. They will not spare you. It's very important. Do you get? So please learn it now. If you have questions, please ask. Please ask. All right. So georeferencing. So what I did here, I just come on this part of the interface and right click, and I'll look for georeferencing. I'll toggle it on. By toggling it on, I have it here. So I can like leave it open, but I don't use it all the time. So I mean, I don't leave it open on my interface. So I'll come to georeferencing. My georeferencing tab is on. My georeferencing tab is on. So the first thing I want to do is to uncheck auto adjust. I want to uncheck auto adjust. So if you leave auto adjust on, it means that once you insert the first coordinates, your image will turn to the area of that coordinate. Once you insert the second one, so you won't be able to insert the 4 coordinates correctly because your image will be spinning on its own. It will be turning on your own. If you know what that means, if you don't know it, forget about it. So after we have toggle auto adjust off, hit the display if it's on, uncheck it. Whatever is on this list, just uncheck it. And like I said, we can like upload the points, but we are going to be adding them one after the other. So we'll come to this icon, you click it and you zoom in. Also, people do GIS without mouse, but I don't know how they do it. I think I need a mouse. So you do it, you left click, then right click. You left click to click that point, then right click to bring out this tab, right? And you go to impute X and Y. Impute X and Y. So we'll go back to where we saved our coordinates, right? So the first one, I think even everybody here knows that X is easting and Y is nothing. In case you didn't know, please note today that your X value is talking about your easting and your Y value is talking about your nothing. Your X value is talking about your distance and your Y value is talking about your nothing. So if you remember, intentionally made it this way because I'm a surveyor. I always remember that my AutoCAD is distance, nothing. So I already know that in the way I arrange my data, this thing comes first. I don't have to think which one is distance, which one is nothing. So, and for a fact, Google Earth will tell you which one is distance, nothing. So just arrange it in a way that you understand. So after I've inserted the XY, I'm clicking OK. If there was auto adjust, this thing would have just rotated to that particular coordinate. I'll be giving me stress to now locate the second point. So after I've done that, I'm going to the second point. So if you have any issues like this, what's that? Okay. Redo, undo. Okay. Okay, I don't know if that one went. So I mistakenly clicked a point and I tried to. So you try as much as possible. So I'm trying to re-enter this. Let's start the process all over. Left click, then right click, insert your coordinates. So because of that simple error, this image might eventually not give us, might not be straight, might not be as smooth as we want it. But yeah, that's one. So we navigate to two. So you can always come here and go to zoom to layer. You don't want to stress yourself. So that's one. This is our second. You left click, then right click to impute the coordinates. Go back to the data that was saved. Attention fan, people are running away. Okay, go back to the data that was saved. X, then Y. X, then Y. Y. Okay, then Y. All right. So all right. So I think I'll stop sharing my video. Okay, so you guys should not have this again. All right. So X then Y. I've imputed X. I've imputed Y. All right. So that's okay. And the next one is navigating to the third point. Don't forget, you can always just zoom to layer. You're navigating to the top point. Yeah. Okay. So I open where I see my data again. Okay. I open where I save my data again. And Eastings, X, and nothings. Go to nothings. Yeah, nothings. Then we click OK. I hope you guys are following. Zoom to layer. Then we'll look for the fourth one. Left click, right click, input coordinates. Open your data. Eastings, paste, then nothings, paste. Thank you, Jesus. All right. Paste. All right, so we have all the four controls established now. So what we want to do next is to go to georeferencing. Then we click on update georeferencing. Update. Somebody has a question, right? Okay. Ben, you're following. Okay, thank you. I see you. So you come to update georeferencing. Of course, it will disappear. You know why it disappeared? It has thrown this image to the coordinates we just imputed. So what will come is right click on this and go to zoom to layer. Boom, our picture now has spatial coordinates attached. Okay, so I'll show you how we know that is attached now. So as you can see now, if you click on any area, if you are looking at this part of the screen, here, you can see the coordinates now. Apart from they compared to the minus whatever I was bringing. So now we can say that sports center, we want to get the right coordinate of sports center. from this image, you can now get it. You can now get it. So our work is done. We have successfully georeferenced this image. All right. So guys, I think we are good to this point. Please let me know. Let me know. Let me know. Let me know that you're following to this point. Please, I need responses. Thank you, Jose. All right. I just hope you guys are following, because there's no point going through all of this if you guys are not following. So we are good to this point. We all agree that we are good to this point. I don't want to hear I do not understand. So I mean, we are done with georeferencing. You can remove it if you like. You can leave it there. So for me, I don't like, so I will remove it. So the next thing I want to do is to start working. Like we said that GIS is all about a lot of things, and one of it is making maps. And not just make maps, we can build. We now have spatial data on this. And we can have attribute data, and we can also make decisions with it. So the next thing I want to do is locate the file you are working on. Like I've told you guys about file geodatabase, right? So I want to create a database that will host all of our data. I want to create it on this folder. So I'll come here. I'm trying to locate the folder that we're working with, and this is it, guys. This is it. So this is the folder. So from this folder now, I'll right click and come to new and come to file geodatabase. So the difference, like I said, we have file geodatabase, we have personal geodatabase. The difference between the two is file geodatabase is like open. I can send it to anybody. For personal geodatabase, it will be for me and for anybody I give access to. You understand? So if you want to like lock, you want to make your data private, you can use personal geodatabase. But if you want to make it open that you can send it to anybody and they will have access, you can use you should use file geodatabase. So I'm creating a file geodatabase, and every other thing that I will be doing will be inside the file database. When I was telling you about extensions, you can see the extension is .gdb. So I will rename my file database if I want. I can leave it open too if I want. Don't forget, I ensure that I'm saving it inside the folder. Folder is very, very important in GIS, because you don't want to in anything, because you don't want to start looking for your data up and down. So next thing to do is to click on your file database, right click again, and go to new. So now we want to start creating our feature class. So feature class is like a standalone feature that something that we like we said, we want to turn this raster data into a vector data. So we want to like represent these things with points, lines, and polygons. So what we'll do is we'll create feature class. We'll name it what we want. So say we want to name this road. So this is where GIS gets interesting. As you go into it, you know that there are classes of road. We have minor road, we have major road, we have footpaths, we have I mean, there are a lot of classes of roads. So for this tutorial, we'll just do roads, and the alias is what we like. So we can just use Audi. And for road, the future we want to use, what we want to represent road is line. Want to use line features. So why it is important to declare your reference system from the beginning is why when we are doing all of this, so you don't have to like go through the see, this is it's asking us to, but since we have done it, it has already selected itself. So we just press next. Okay, so this is where the attribute data comes in. This is asking what description of the day, what do I what information do I want to get from the data? Do I want the name? So for me, of course, I'll tell you that I need the name, and the data type will be in GIS. You have a lot of data types. You have short integers, you have long integers, you have floats. Short integer will just be your number. Long, you want first long number. Float is when you are working with decimal, and text is, I mean, normal text. So those are the ones that we use often. So we are going to be, we are using text for the name. So for road now, we can say we need the length. We can say we need the length. All right. So you can say we need the length of the road. And for the length of the road, of course, you agree with me that you always have decimals. So, I mean, that's just the example. You can have as many fields as you need to have on this. And don't worry, if you have created this and you remember more fields to add, you can always go back to add it. So I will do a little of this and allow you to do the rest. Ooh. Okay, I hope people will do it, because people did not do it last week's assignment. It's fine. Okay, so that's for road. So once you create it, to show here, so this is our first feature class, right? Road. We have defined it. Next one, want to create another one. As you create it, they will add up there. We want to create another one. Don't worry, we'll close by 8. Whatever we do, we'll stop by 8. And yeah. So the next one we want to do is probably buildings. Buildings. Okay. Let me remove this one. Okay, buildings. Where is the early now? They taught me in FSS. God, you want to embarrass me. Okay, buildings, right? Building, and we can just call it BD for short. And normally, depending on the project, depending on your area of interest, you can use polygon for buildings, and you can use points for your building. So for this, say you're working probably on a street guard map, or you're working majorly on the road network, you can just use points for your building. But say you want to like analyze the access routes of a particular building or a particular settlement to a particular road, how the road access can be improved, and you need the buildings on polygon. So if attention is placed on buildings, you have them on polygon, so that you have the size, you have the area of those buildings. But if there's no much attention, then you can just use points, so that you just know which building exists where, right? So we are going to be using points for this. Ooh. So you can for buildings now, attribute data can be name, of course, text. You can have name, color, and the likes, right? So yeah, that'll be that. Then the last thing we are going to be creating for this training that I'm going to be creating for you guys, it will be river. So I know that that's a feature class we cannot ignore if we are talking about Lagos. So that's river. There's a river inside of me. So you can just give it RBR for a short, and of course, going to be line features. So you press next. All right, and so yeah, we are done with that. So another thing I want to show you before we leave tonight is how to digitize. So we are just going to like digitize one or two, and I will give you the rest for an assignment. So for ArcMap, you just need to come to editor rather, come to editor, go to start editor, start editor. So it will ask you which of this thing you want to digitize first. So let's say river. Let's say river. Okay. So you click on river. It lacks spatial reference. Yes, because we just created it. So yeah. So once you click on river, look at what it's bringing. Can't digitize with this, guys. I can't. So what will I do? So just come to create features. Sometimes it might not be here. You can also just right click or put it. This is the great features here. It's on the editor, it's together with it. So if it is not out here, you can always just click on it, it will come out. So you click on the same thing you told the editor you want to edit, you click on it on create features, which is river. So I mean, there are classes of rivers too. So what you want to do, the principles of digitizing is that no line must cross each other. So I can't have a line like this. Now see another one cross it like this. It is not possible. It means so I mean I must finish this part. First I can do is join it together. So if take for instance this road now. This road, as you can see, is crossing each other, but in reality, it's not like the only reason why I can say the line cross is because if there's a river like this and there is a bridge which the road crosses on top of it, so this line can cross on top of it. But for this one now, it has to like join, end this one here, continuing there, can finish part of that. So please very note that, because when you're doing analysis, those are the things that will count, right? So I've picked my editor, I've specified the features I want to create. So I will just start. So once I place this mark, I will let's click and start tracing what I want to digitize. I'm tracing it. The moment I knew how to digitize in school, I thought I was a GIS specialist already. Oh, funny. It might not be funny to you about until you know what GIS is all about. You know that this is just like 1% of what GIS can do. Digitizing is just like 1%, like 1%, guys. I'm not kidding. 1%. All right, so I start digitizing. This is what I'm doing, putting these lines now. I'm saying you this road that you are paying as a picture, I want you to appear as just a line, as just a line. Okay, so yeah, 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 yeah. So I'll like digitize this guy. I mean, our time is fast spent. So I'll digitize. Once I'm done, I get to the end, I'll right click and come to finish sketch. So like the one I was telling you, if I'm digitizing this line now, I can finish, come here and click on finish parts. And once I finish, so let me quickly show you an example. So I'm coming on this line, I get to this roundabout. So I can like put it here and say finish parts and continue. So when I now get to the end, I will now say finish sketch to count it as the same line. It must not just overlap, right? So yeah, so that's like the principle of digitizing. And as much as every time you digitize, always come to save edit. Save edit. Once you are done, say I've digitized all the rivers on this map now, and I'll just like say stop editing, and I'll always save your map, guys. Always save your map. I mean, I'm working with the I've like done a whole day job and the system crashed and I could not accept a whole day job, guys. It was crazy. I could not cry. I think I cried. I don't know. So that's the principle of digitizing, guys, and that'll be the end of the class today. I don't know if you have learned anything. So I've said a lot, and to be honest, if you're going to find a career in GIS, this is the basics of what we do. This is the basics, and like I say, and I'm not kidding, this is like 1% of what you do, either as a GIS specialist, or as a GIS analyst, or as a GIS developer. Those are the three leading roles we have in GIS, right? So either of the three, I mean, all of this is elementary to what you do. It's just 1%, just like we are doing chain survey in Dublin, right? So I'll put a stop here. I would expect that you guys continue from here. Finish digitizing the buildings, digitize the rivers, and digitize the road. And if you can, my my email will be shared on the group. You can send it to my email. You can enter my WhatsApp inbox. Any of it will be allowed. I mean, I just wanted to get better. And like I said, practice makes perfection. So without practice, all of the story I just said in 2 hours is just story. You don't practice, because the faintest pen is sharper than the sharpest brain, right? So cheers, guys. Thank you for staying till now. I'll take questions now. If there are no questions, we'll call it a day. So questions, please. If you have questions, please go ahead and ask me. If you have questions, please go ahead and ask me.